Hey everybody, thanks for joining me today. We're going to go through tables and graphs, and part of this means we have to start adding in x and y to our equations. That's actually how we're going to start this off. Consider y equals 4x plus 1. Are these ordered pair solutions? So basically, if we had that graphed, if we had a line, and that line was y equals 4x plus 1, would the point 313, as in x is 3 and y is 13, would that point be on the graph? And so to test it out, you plug in 13 where the y goes, you plug in 3 where the x goes, and you're just kind of giving it a yes or no at this point. 13 equals 4 times 3 is 12 plus 1 is 13. So yes, that point would be on the graph. All right, let's try it out here with x being 0 and y being 4. So you would say 4 equals 4 times 0 plus 1. All right, 4 times 0 is 0, plus 1 is 1. That is a no-go. All right, try the point 1040. So that'd be example number 3. So x is 10, y is 40. So you've got 40 equals 4 times 10 plus 1. 4 times 10 is 40, plus 1 is 41. So that was close, but that one is still a no-go. All right, last test here, example number 4. X is -2, y is -7. So you've got -7 equals 4 times -2 plus 1. All right, so you've got -7, and I'm going to be a little more careful with this one because we're dealing with negatives. 4 times -2 is -8. -8 plus 1 is -7, so it checked out. All right. Example number 5. So, Sean is working for $12 per hour. Fill in the blanks in the table. So, after 1 hour, the money earned was 12. After 2 hours, the money earned would be 2 of those. That looks a lot like 24. I think the pattern is pretty easy to spot in this case. 3 hours, $36. 4, so now you're talking about $12 4 times. 12 times 4 is 48. And then 12 times 5 is 60. Now, if we were to continue the pattern, then we would do 10 hours at $12 per hour. 12 times 10 would be $120. All right, now let's actually make the graph and let's go through it here. Jose's age is X, and when Jose was 4, Jim was 1. Now, I'm not going to go through the labeling here too much because it's set up the way it needs to be. I'm not going to change anything. I'm just going to go through this and make sure we get this thing done. X is 4, going along that axis. Y is 1, going along the y-axis. So 4, 1, that would be the ordered pair. Now, this is going to come as a total shock to everyone, but when Jose got a year older, so did Jim. Oh man, I know, that was pretty crazy. When Jose was 6, Jim was 3. When Jose was 7, Jim was 4. So if we label this graph, and in this case a label would probably come in handy because we have some questions to answer, and I just want to make sure we get them right here. So we've got Jose's age, and then we'll have Jim's age going vertically here. All right. Now, if we're going to graph this, I would like to actually graph a line for this, and it's never going to get into the negatives because you can't be a negative age, but hopefully Jose and Jim will live a long and full life, and this graph will keep going up for a while, and it would look something like this. Obviously, I only gave you one quadrant because when Jose was 2, for example, Jim hadn't been born yet, and so we can't really compare the two numbers. All right, that took care of example 6. Sketch a graph. Check. If Jose was 15 years old, how old would Jim be? So we're looking for a pattern. I mean, that's a critical part of understanding this lesson here. Can we find a pattern? Well, Jose was 4, Jim was 1. Jose was 5, Jim was 2. Jim is going to be 3 years younger than Jose. So that means, how old would Jim be? In this case, it would be 12 years old. All right, example number 8. Would 1720 be on the graph? Why or why not? Now, if we actually extended that line all the way up here to where you got to 1720, you'd be way out in outer space. That wouldn't really help us very much. So we're going to have to sort of make an interpretation based on what we see here. Now, I'm going to go back and I'm going to look at the ordered pairs. And I'm going to say, well, the first ordered pair in the table here was the ordered pair 4, 1, which meant y was 3 less than x. And then 5, 2, sort of the same idea. Y was 3 less than x. So when I'm looking for a pattern here, I'm expecting the y value to be 3 less than the x value. The problem is, if you look at the ordered pair that you were given, 1720, the y value here isn't 3 less, it's 3 more, which means that ordered pair would not be on the graph. All right, now let's be careful with our description. Let's do our best here because descriptions are becoming more and more a part of testing. We're not just feeding things into a machine anymore. We're actually reading descriptions. So make sure you describe it the best you can. Would 1720 be on the graph? Why or why not? It would not be on the graph. And we need to come up with a good reason here. It would not be on the graph because, and I'm going to squeeze it up here because we're going to run out of room, we need the y value to be 3 less than x, not more. Now, obviously, your description and my description are going to be different. Depending on how much room you have, depending on how good of a writer you are, you probably phrased it a little better than I did. But the key here is to demonstrate that we were expecting y to be less than x, but in the ordered pair they gave us, it turned out to be more, and that's why it wouldn't work. All right, thanks for joining me. I appreciate it. Good luck the rest of the way.